Hey everyone. So today we're going way beyond just writing a single prompt. We're going to talk about how to chain them together to build these really smart AI workflows. The kind that can handle the really complex stuff that makes one single prompt just fall over. It's super tempting, right? To just cram everything you need into one giant prompt and just cross your fingers. But let's be real, as soon as things get even a little bit complex, that whole approach just starts to completely fall apart. Okay, so picture this. You ask an AI to do, well, all of this. Analyze feedback, find the top 5 issues, write a summary for the bosses, and then draft 3 different emails. That's analysis, summarization, and creative writing all at once. Trying to stuff all that into a single request? Yeah, that's just a recipe for disaster. And yep, this is usually what spits out a total mess. The model gets confused, it tries to do everything at once, so you get a summary that's got bits of an email mixed in, and it probably even forgot one of the key issues you asked for. It's just not reliable. So how do we fix this?
Well, the answer is something called prompt chaining. The idea, and this comes from Anthropic, is pretty simple but powerful. You break down that huge, messy task into a bunch of smaller, bite-sized subtasks. And here's the magic. The output from one step becomes the input for the very next one. You're basically creating an assembly line for the AI.
And listen, this isn't just some cute little trick. It is wildly effective. Get this. Research from Anthropic showed that using these kinds of chain systems led to a, wait for it, 90.2% performance boost compared to just using a single big model to do everything. That's not just better, that's a whole different league. All right, so here's what we're going to cover. We'll go from the basics to the advanced stuff, check out what the big companies are doing, talk about the common mistakes and how to fix them, and then see why this is basically a whole new field of engineering. Okay, let's get into the main difference here. Think of a basic chain as a really simple assembly line. Step A, then step B, then step C. Always the same. But advanced chaining, that's more like a modern smart factory. It can make decisions, check its own work for quality. It's a whole lot smarter. This table lays it out perfectly. A basic chain, it's rigid, linear. If it makes a mistake, too bad. An advanced chain, on the other hand, is dynamic. It's smart. It can take different paths, it can actually fix its own errors, it can remember things from earlier steps, and even change its plan midstream. It's a game changer. So, how do we actually build one of these smart factories? Let's open up the advanced toolkit and look at the real techniques that developers are using to build serious production-level AI systems. First up, we've got branching. This is basically a fork in the road for the AI. Think about it. The system could read some customer feedback and first decide, is this positive or negative? If it's positive, it sends it down one path to, say, write a nice thank you note. But if it's negative, boom, it goes down a completely different path to a specialist prompt that knows how to handle complaints. It's decision-making built right in. Okay, next up is validation loops. This is your quality control inspector. It works like this. The AI generates something, then another part of the system, another prompt, acts like a critic. It checks the work against the checklist. Did you follow the format I asked for? Is this summary short enough? And if the answer is no, it sends it back saying, nope, do it again. This can happen a few times until the output is perfect. And this whole idea of self-correction, it's not just a nice to have, it's a huge deal. Anthropic themselves point this out, saying that having the AI review its own work is absolutely crucial for catching mistakes, especially for those really high-stakes tasks where you just can't afford to be wrong. Now, this isn't just theory, right? These are real techniques being used by the biggest players in the AI world, and they're building entire frameworks around them. So let's take a look at how the pros are actually thinking about this and putting it to work. What's really fascinating is that all the big labs, we're talking Anthropic, Google, OpenAI, they've all basically landed on the same playbook. Decompose the task, use structured formats like XML to keep things organized, force the AI to think step by step before it gives you the final answer, and probably the most important thing, treat this like a real engineering discipline. You have to test, you have to iterate. I love this quote from the Anthropic docs. They say, always have Claude output its thinking. Without outputting its thought process, no thinking occurs. This is so key. It's not just about debugging. They're saying the very act of forcing the AI to write down its reasoning is what makes it reason better. It's a wild but powerful idea. All right, so building these things sounds great, but it's not always easy. There are definitely some common traps that people fall into. So let's talk about the biggest pitfalls and, of course, how you can get around them. Okay, here's a classic one, context loss. The AI has a short memory. By the time it gets to step 4, it's completely forgotten a key detail from step 1. The fix is actually pretty simple, but so many people miss it. You have to remind it. In each new prompt, just restate the most important bits of context. Don't assume it remembers. And another huge one is what we call error propagation. A tiny mistake in the first step can snowball, getting bigger and bigger until it completely wrecks the final result. The solution? You gotta build in safety checks. Use those validation loops we talked about as gates between each step. They'll catch and fix errors before they have a chance to mess everything up. We also have to talk about cost and speed. And this chart shows something super important you need to know. See that? Output tokens cost way more than input tokens, often around 4 times as much. So what's the takeaway? If you want to save money and make things faster, the #1 thing you can do is make your outputs shorter and more concise. Tell it to be brief. It makes a huge difference. So when you pull all of this together, it's pretty clear what's happening. Prompt chaining isn't just a hack or a clever trick anymore. It's evolving. It's becoming a real, honest-to-goodness engineering discipline, with its own best practices, its own design patterns, and its own set of tools. So, what are the big takeaways here? 1. Structure is everything. Breaking the problem down into smart steps is way more important than writing one perfect giant prompt. 2. Self-correction is non-negotiable if you want a system you can actually rely on. 3. The hardest part of this whole thing is managing the AI's memory from one step to the next. And finally, 4, treat these chains like code. They need version control, they need testing, and you have to monitor them. And that leaves us with one last big idea to chew on. When you're building these complex chains that can remember things, correct their own mistakes, and make decisions, you're not really just prompting anymore, are you? You're designing intelligent, autonomous systems. So the real question is this the first glimpse of what all software development is going to look like in the future?